Hello. So in this video, we are going to be talking about transformations. So in particular, we're going to be talking about sort of how transformations work and the sort of various types of transformations from a geometric point of view, meaning that we're going to look at graphs and what's sort of happening visually. And then sort of in another segment, we're going to deep dive more into the analytic process, the algebra, and how to actually represent this with functions and all of that crazy nonsense. So as a starting point, transformations come in a couple different ways. So the first one we're going to look at is horizontal transformations. So when we say transformations, we largely mean some kind of stretching or compression sort of version. So for example here, I could stretch this out and make it sort of twice as wide. So this would be an example of a horizontal transformation. Likewise, like if I put it sort of going backward, it would be sort of half as wide. That would be a compression or a stretch to half the width. So whichever way you sort of want to say that. Another example would be a vertical transformation, which again works pretty much the way you would expect it to work. What we want to do is we want to sort of stretch it in a vertical way. So we want to think of like having this on some sort of stretchy material, and we sort of stretch it out, and it ends up getting sort of pulled up. And just so we can sort of see what happens is that this is pulled, but it's pulled uniformly by some sort of constant multiple, meaning that if I look at the original function, right, each point on the original part, so if I look at, say, this value here, right, this point on the graph here, this length gets sort of multiplied by some amount to get to the next one. So it goes up to like here. So this thing, if I'm getting sort of twice as large, each point along the part, like down here, the blue part is going to, if you multiply that sort of height by 2, that's where you would get the red, and that's true everywhere. So this is the idea, is that when you stretch it by this uniform sort of value. Everything gets twice as large, or everything gets half as large in whatever direction, okay? So the other thing that's sort of a unexpected twist, to use a horrible pun unintentionally now that I think about it, is that transformations can also flip the graph. So transformations, we're used to it well, maybe not used to it, but I've introduced it as stretching, right, one way or the other. But the other thing you can do is flip, and it can flip in either direction. So it can flip this sort of left to right, and it can flip up down, either one. But again, to see sort of what happened, if we look at the original graph, essentially we just took all of, in this case, the x values and made them the other version, right? We made them all sort of the negative of what they were. So the positives became negative, the negatives became positive. But I would have gotten, in this very specific case, not in general, but in this very specific curve, right, I could have taken it and flipped it up down, which would have also gotten the red sort of line, because this is what we would call an odd function. So this, because of the symmetry of the actual curve, I could do the same thing in the vertical direction, right, where the y's that are positive becomes negative, or the y's that are negative become positive, and that's how I would get this other shape involved. So again, in general, those are not the same, but in this particular example, we can see that flipping it, right, one way, either the y values or the x values, that is also a type of transformation, okay? So in particular, right, if I look at this length, right, so this length is my positive x, let's say, then I would go the same length, but I'm now going to the left, so I get the negative x. Likewise, the negative, right, the new one down here was really flipping the previous one down over here, right? So this negative value I flipped over to get that new positive value, okay? So what do we do? Well, we talked about transformations. We did the sort of geometric understanding. We looked at the pictures of what it means. And really transformations, what they are is stretching, right? We stretch it either horizontally or we can stretch it vertically. And then we have this weird sort of situation where we can flip it either horizontally or vertically. That's also a type of transformation. And how we tell sort of which one is which, or how we know how that's happening, that's something we're going to dive into with the analytic view, which we're going to do in a different segment, okay? And sort of last but not least, just to be clear, when we talk about stretching, this is sort of stretching to make it bigger or stretching it to make it less big, which normal humans would say compression, right? So it's stretching or compressing, but it's that same idea of sort of manipulating it so it sort of has a constant multiple, one to the other, okay? So that is that.